Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to go over an exercise where we have two limits to be evaluated, and we're going to use what's called special limits to evaluate the given limit. So let's go ahead and check what those special limits are first. All right, here are three special limits. The first two are trig related, and the last one is transcendental related. In fact, it's number e coming out of this limit operation. So let's check out the first one real quick. So we have the limit of sine x over x as x approaches 0 to be exactly equal to 1. And we have the limit of 1 minus cosine x over x as x approaches 0 to be 0. And finally, we have 1 plus x to the power of 1 over x as x approaches 0, providing you the limit value to be the special number e, and you can take this as the definition of the number e. So let's see how those special limits are relevant to given limits in the exercise. Right, first off, to be able to use any of the special limits, we must have limit of a function as x approaches 0, and that's the case in part A, and in fact in part B that's the same deal. So we have sine x over x as a special limit, but we have sine 2x over sine 3x. So can we make the given function look like sine x over x type limit? Okay, so what we're going to do next is to try to tweak sine 2x over sine 3x. So first of all, I'm going to get the sine 2x and divide this all the way by 2x and then multiply by 2x. So this is the trick, at least for sine 2x part. And for sine 3x, well, that's in the bottom in the original version. Okay, I'm going to multiply this by 3x and divide by 3x. Okay, so now these two guys look like almost the same as the format in the first special limit, that's sine x over x. And what am I going to do with the rest? Well, I'm going to combine these two guys. So all in all, we have sine 2x over 2x, 3x over sine 3x, and 2x and 3x combined gives you 2 over 3. Okay. So next I'm going to use the property of the limit. So limit of the product is the product of the limits as long as those limits exist. All right, let's now pass the limit by using the property I just mentioned. So this is the limit of sine 2x over 2x, the limit of 3x over sine 3x, and the last one is a constant, so you can just like write the constant as is, which is 2 over 3. All right, as you see here, that 2x and 2x, so the argument of sine is 2x, so the bottom is 2x, same as here, 3x and 3x. So these guys share the same, like sine has the argument 3x and the bottom has 3x. So that sort of like lines up with this limit, the very first limit, because the argument of sine is x and the bottom is x, and as x approaches 0, this limit is 1. So I'm going to deduce that this limit here has to be equal to 1, as well as this limit, even though, you know, the 3x and sine 3x are like got flipped, it doesn't matter because the limit value is 1 and the reciprocal of 1 is just 1. So we have the same limit here. So it turns out that the whole limit is equal to 2 over 3. All right, let's stare at the second limit problem. So we have cosine x minus sine x minus 1 over 2x. And I forgot to tell in the first part, but these are all like 0 over 0 indeterminate forms. Okay. And same as this one, because if you substitute 0 for x, then you're going to have cosine 0 to be 1, sine 0 to be 0. So 1 minus 0 minus 1 is 0. So the top is 0, bottom is 0. Then you have 0 over 0 type indeterminate form. And without using the special limits, there's no way to come up with the limit values for the given functions without graphing them. Okay, here we go. So well, what I'm going to do next is to make this fraction resemble the fractions here in the first and the second one. Okay, so I'm going to combine cosine x with -1. So essentially, I'm going to rewrite that fraction as cosine x minus 1. In fact, let's pull out the 2. So I don't need 1/2 here. So 1/2 out. Cosine x minus 1 over x minus sine x over x. Okay? And you can also rewrite this as like 1 minus cosine x if you want to by pulling out -1. But it's not going to matter. All right, let's pass the limit. So this limit is going to be equal to 1/2 limit of the first piece minus 1/2 limit of the second piece. Okay. And as I said, I can pull out the minus here, so I can rewrite this as 1 minus cosine x. I can put a -1 here. Okay. So now this is the exact same limit and one of the special limits, and this is also same as this is the first one, this is the second one, right? If you go back to the table here, okay. So these limits are all 0. Okay, so this is 0 sum. There we go. We end up having 0 for the limit value here. So this is equal to 0. All right, this was the application of special limits to come up with other limits, and we used these two limits to evaluate other limits, and in both of them, just realize that we have 0 over 0 type indeterminate forms, and without using the special limits, it's not possible to evaluate these two limits given in this exercise without using a graphing calculator. The graphing calculator may help you how the functions behave around 0, but to be able to be rigorous, you have to rely on the special limits. All right, so this is the end of the video. Thanks for watching. I'll see you in another video. Bye.